Hello, welcome to another segment Geospatial tutorial. In this video, I'm going to show you how to segment remote sensing imagery with box prompts. First, let me show you how to download the notebooks. So if you go to the website, samgeo.gshub.org, the link is also in the description. And on the left side, click Notebook Examples, and then Box Prompts. So this is a new feature that I just added today. Essentially allows you to segment remote sensing imagery with multiple input prompts. Makes it really easy to use. You can provide any vector data. If you already get some bounding boxes from some other machine learning models or from whatever data sources that you can get, and so you can use that to inform the segmentation. So if you scroll down to the end, I can quickly show you the results. So the yellow bounding boxes are the one that you can input into the model. So given an imagery, and then you can provide the bounding box, then we can utilize the segment anything model to segment the object. So basically refine the object, not just the bounding box. Now you really get the object within the bounding box. It's really useful and very easy to use. Previously, I already created a tutorial that shows you how to segment using points or text prompts. So this is the box prompt is another requested feature that I just implement today. So it took me a while to actually get it done. And so in this video, I'm going to show you how to do that. So upper right corner, if you click the download icon, then you can download this one to your computer. Once it's downloaded, then you can open using Jupyter Lab. So I'm going to just type Jupyter Lab and hit enter. It's opened it in the browser. If you don't have a GPU, so this is recommended you have a GPU. If you don't, you can try it on Google Colab. So just right click, open in new tab, and you should open this one in Google Colab. And once it is open, click runtime, change runtime type. You want to change this one to GPU. CPU is pretty slow, so if you change to GPU, it should be much faster, and then click save. The first step is to control slash to uncomment this one, and then just click run. Then just follow step by step. You should be able to run the notebook just using the browser without having to install anything on a computer. The only downside is that you have to install the package every time, and also the map displaying the raster is a little bit buggy. It's not as smooth as running locally. So, but you're welcome to try that out if you want. And for the remaining of this tutorial, I'm going to just show you how to use that locally, and assume that you already run this, already install the packages. If you haven't, you can just go to the installation and then just use Mamba to install the package, and then you should be able to use that. So first step is to import the libraries, and we're going to import leaf map and also SamGeo. We import basically two functions. The first one is the TMS to GeoTIFF, allow us to download time map service to a cloud optimized GeoTIFF. And the second one is the SamGeo, the class that we can use to segment imagery. So first, let's create a map and then center around somewhere, latitude, longitude, wherever you like, the zoom level, and also the height. Then we also add a base map. So take a look at this here. This is the base map. So behind the scene is the Google satellite base map. And once you have that, you can specify region. So you can use the drawing tools to draw a rectangle on the map. Then we can download it. So if you don't draw the rectangle, it's going to use this by default, this bounding box. So the latitude, x min, y min, x max, y max. So basically just the lower left and upper right corner, the coordinates. With that, then we can use the function to download the imagery. So TMS to GeoTIFF, and the output, this is where you want to save the imagery. So we're going to save that as a file name, image.tif, basically under the current working directory. And then the bounding box, you are specifying where the region you want to download the data, and the zoom level, and the source basically the source of the base map. So this is the Google satellite, but you can try out some others. And the last one is whether or not you want to override. So just run this one. You see it's pretty quick. So it's basically downloading the tiles and then mosaic them back together as a single geotiff. Then on the left side here, you should be able to see this image stock tiff. So this is how you can download the imagery. Of course, this is just for educational purpose only. If you're trying to download a large amount of data, you probably violate the term of service. So always make sure that you have the license to use the imagery. But there are tons of other imagery online that allows you to use freely. The reason I use this one because it's all at a global scale, so you can try out anywhere you like, but don't try to download a large amount of data. Okay, so once you have the imagery, then we can just add the imagery on the map, and this line basically is to hide the base map and then add the raster that we downloaded. So if you want this one again, now you should see this imagery that we downloaded. So this is the image stock tiff, the imagery. You can upper right corner here, click this one and then click here. You can turn the layer on and off. You can also change the opacity if you want. So the Google satellite base map is still there, but it's just hidden. So this is the map, basically the imagery here with, I'm not sure why, because of opacity. So let me turn it back on. Okay, so you see it's pretty clear. And what we want to do is to, for example, segment the trees from this imagery, right? So you're trying to do the manually delineation, it's going to take a while. You're also welcome to use other deep learning models to do that, but you need to have training data, and then you need to do build the model, and then you need to do the segmentation and do the validation. But using the segment geospatial, all you need is just imagery, having the bounding box, and then you can do the segmentation without requiring any training data. So next, let's see how we can do it. So you need to initialize the same geo class, and this one allows you to specify the model type and also the track point and whether or not you want to be automatic. Since we're going to provide the bounding box, we don't want the automatic mode. So this basically disable it and just run this one. It might take a couple seconds. So this is going to initialize, and this step might be take 10-20 minutes, depends on internet speed. If this is the first time you're running this one, you don't have the track point yet. So the track point itself is 2.4 gigabyte. Since I already downloaded on my computer and I've done it before, it's already downloaded on my computer. So I can quickly show you where it's located. So it's under the home directory, and then under cache, from here I think it's torch, and then hub checkpoint. So this is the checkpoint that has been downloaded, 2.4 gigabyte. If you don't have this on your computer, it's going to take some time to download. So just be patient. Once it's finished downloading, then we can just set the imagery. So this is the step that you need to do is to specify the image you want to do the segmentation. So this variable, if you come back to this step here, is image stock tiff. So basically this imagery. So we want to segment this imagery and just shift enter. It's going to take some time. So depends on your computer configuration. This can take 1 to 2 minutes. Just be patient because it's reading, basically it's reading this checkpoint, loading into the GPU, and then so that we can do the segmentation. So this is the most time consuming steps of the entire notebook. Just make sure that you wait. If you have a very small GPU, sometimes it might throw a RAM memory issue. That means that your GPU, you run out of the GPU. So you can either try a smaller imagery, or you need a larger GPU, or you can try Google Colab or other cloud computing platforms that has a sufficient GPU. So all the segmentation stuff, computer vision, you need a decent GPU. Okay, it's done. So take a look here. We already finished this step, and then the next step is to show the map again. So I'm just going to show you what I'm going to do here. And there are different ways you can provide the bounding boxes. You can either create the bounding boxes interactively on the map, or you can just provide a vector, a file path to a vector data. So I'm going to show you two ways. The first way is to create the bounding boxes interactively. And all you need to do, click the drawing tools here, and there are a lot of trees. So if you want to extract a specific one, for example, I want to extract this tree, so you can just draw a rectangle around this tree somewhere here, right? And you're welcome to extract more, so you need to click again, and maybe this one, okay, like this. You can, oops. So this is the back of the iPad leaflet. If it doesn't stop, you just press escape key on your keyboard, then it should be done. So here, basically, we just drew two rectangles, and we want to extract the trees within this rectangle. All we need to do is draw the rectangle, and then since we drew the rectangle, so the rectangle is not none. If you want to check it, you can click a new code block and then just type m.user RIs, because we draw multiple rectangles. So if you want to get more both of them, you need to use the RI. So this one essentially is the JSON dictionary. So you can see within here we have the coordinates. We also have basically have two. So if you draw more, you want to have more geometries within this dictionary. And once we have this, then we can segment the imagery. So what we want to do is to call the same geo class, right? So if you go, remember here, we create the same geo class, and then we specify the imagery. Then you can call this function to predict. So the predict, this same class already have the image encoder, so we already have the imagery. Then for the predict, you can press Shift tab on your keyboard to see the input parameters, right? So you can input the point coordinates. You can also provide the label, but in this case, we're just going to use the bounding box. You can use them together if you want to, but for simplification, I'm just going to provide the bounding box. So the bounding box, you will see here, the bounding box is this one. So basically, the bounding box are the two one that we just draw there. It's coming from the m.user RI, right? So if you draw something, it's going to pass those two bounding boxes to this variable. If you don't draw anything, it's just going to provide a list of two bounding boxes. Again, this is from the x min, y min, x max, y max. So you're welcome if you know exactly the location, the coordinates, you can provide them. But sometimes it's very difficult, so it's easier to just draw a rectangle on the map and then grab the dictionary and then passing to this one. So here we just directly passing the variable, and so this variable can be the parameter accepts a list, a dictionary, or a string of a file path to a vector data. So right now we're using the second one, so this one right now is a dictionary, okay? But you're welcome to provide a list of any bounding boxes you want, and then you need to specify the coordinates, because the bounding boxes, if you see from this one, for geospatial data, usually you want to use some kind of a coordinates. So this is just the latitude and longitude. By default, the coordinates will be none, right? So in here, coordinates is none. If it's none, then you need to bounding boxes. You basically need to provide the row and column number of the imagery. So this is a little bit challenging, because if you giving imagery, even if I draw here, it would be difficult to know like what's the row number and the column number. So the row and column number is counting from the top left corner, right? So if you like 100 rows, 100 rows, for example, horizontal, and also vertical is the column. Yeah, and it's challenging, so I would recommend just using the coordinates and then just specify EPSG 4326, so the WGS84. That's it. So what we are telling the program is that, okay, I want to give you two bounding boxes, and the coordinates is the WGS84. Then I want you to segment the imagery, the object from the imagery, based on those two bounding boxes. And the output, the D type, is basically the output image data type. So just run this one, it should be pretty quick. So it's done. Then you see we have the mask octave. If you refresh on the left side, you see this mask octave. So it's done. Once you have the result, then we can add the raster on the map. So we're going to use the add raster, and then this is the file path. This is how you want to visualize the imagery using a color map. And you can also specify the no data, because this is basically a binary imagery. 1 means the foreground, 0 means the background. So, and then you can also specify a layer name and then just run it. Take a look. So pretty easy, right? So now the yellow color represent the object that we extracted. So you can zoom in here. Of course, this is exactly what we want, right? So we draw the bounding boxes, and then we want the algorithm to be able to extract the objects within the bounding boxes. And if you turn this one, you can turn the layer on and off. You can just compare them, right? And you can also change the opacity. It actually does pretty well, right? If you don't want the bounding boxes anymore, you can just click the button and then clear them. So now you can see this more clearly. And it's much better than the bounding boxes. So now we have the perfect object segmentation of this imagery. But this is only have 2 objects. There are so many trees, and this is why if you will have the bounding boxes from other algorithm, from other deep learning algorithm, they already have the bounding boxes, then you probably want to use the automatic way just to provide the bounding boxes, all of them, and then you can segment all at once. So what we're going to do here is going to use the GeoJSON from this file path. This is the one that actually created using the text prompts. So the text prompt can generate the bounding boxes. So previously in the text prompt tutorial, right, and then you can generate, for example, the trees. So I actually save these bounding boxes and then use as an input. So if you come back to here, this is the file, and we're going to download this GeoJSON. So this is a simple GeoJSON with all the bounding boxes. And first, let's take a look at what it looks like. So just run this one. Basically, creating a map. We add the raster imagery that we downloaded, and this is how you specify how you want to visualize the vector data, and then use the add vector file path, the style, and whether you want to zoom to the layer or not, the layer name. So take a look. So if you zoom out a little bit, and this is what we have, right? For the input, we have a raster imagery, or we also have a vector data set with all the bounding boxes. So if you want, you can also explore here, also the imagery, right? So with that, now we can do the same thing because earlier we used the drawing tools to draw the bounding boxes interactively. But if you already have the bounding boxes, the polygon from existing data sources or from deep learning output, then we can use these bounding boxes to do the segmentation. So it's the same step. So the source code is exactly the same. So the boxes, now we can pass in a GeoJSON. So this GeoJSON is basically this file path. It's the one that we download in here. If you double click, right, this is the GeoJSON. So you can, it can be a shape file, it can be a geo package, it can be anything that GeoPandas can open. As long as GeoPandas can open, you can just pass in the file path. So it can be even a HTTP URL to a GeoJSON or to a zip file that GeoPandas can open directly. That's fine. So here we're going to use this GeoJSON, and then the coordinates is again EPSG 4326. Now we're also going to output. So previously it's mask.tif. Now we're going to have another one, mask2.tif, and the same thing. We're going to use unsigned integer 8 because it's only a binary imagery. So run this one, and some of the coordinates might be out of the imagery boundary because, for example, in the lower right corner here, you will see something like that. So this one might take a little bit longer because there are more objects. I forgot how many. So basically, it's over maybe 100 objects. So it's going to take a little bit longer. And you see, it's done. So mask2.tif on the left side, you see it's here. So then we can add the result back to the map. So take a look. Oops. And here, then we can change the layer, right? You see the trees are in red color and the bounding boxes in yellow color. So you can turn the bounding boxes off, and then you can take a look. Of course, there are some of the trees here they were missed because the bounding boxes were not perfect. So if you have add some more bounding boxes in here, the tree will be extracted. So the bounding boxes were exported from the text prompt, so it's not like 100% accurate. But you get the idea that you can use the bounding boxes and then use the segmentation, just one line of code, then you should be able to extract the object, the mask, from any imagery. And so here, the color map, you're welcome to change to any map property color maps. So for example, we can do greens and then run this one again. See the same there. So if you turn this one off, right now it's the green color. So again, it's very interactive. So you're welcome to explore to use different color map, different bounding boxes, different imagery. So it's up to your imagination, and this is really useful because right now with this you can utilize existing data rather than starting from scratch. So even you can use points, you can use bounding boxes, you can use text prompts. So now you have 3 ways they can use to do segmentation using the segment anything model. Okay, so that's what I want to show you in this tutorial. I hope you enjoyed it, and I will see you in the next one. Take care. Bye bye.